Hi everyone, in this video I'm going to talk about Ferret-v2. Ferret-v2 is a multi-modal language model trained by Apple and published in April 2024. And basically, it is on top of the Ferret version 1. So if you haven't read Ferret version 1, don't worry about that. We will talk about that a little bit. And then in version 2, they have improved it a lot in terms of high resolution specifically. And we will talk about that, like how we can expand the multimodal language model to the higher resolution and how we can do that for the grounding or referencing and some of the other things that currently even like GPT-4o is not good at it. So basically, they're talking about Ferret seamlessly integrate regional understanding into large language model to facilitate its referring and grounding capability. It poses certain limitation considered by the pre-trained fixed visual encoder and fail to perform well on broader tasks. In this work, we unveil Ferret-v2, a significant upgrade to Ferret with three key design. Any resolution grounding and referring a flexible approach that effortlessly handles higher image resolution. So they're talking about any resolution. So there are two ways of actually expanding a model to higher resolution. One is any resolution, another one is upsampling. And they were talking about these two papers. So when they talk about any resolution, they're talking about this. And basically, this paper is mostly talking about like patching the images. When we want to do like high resolution, we can do the same thing, like passing it through the transformer, but with just patching and then combining those patches. That any resolution, very overall, this is how it is look and how it works. Here, when they talk about any resolution, they're talking about that specific paper. The second thing is multi-granularity for visual encoding, integrating additional DINO-V2 or DINO-V2 encoder that model learn better and diverse underlying context for global and fine-grained visual information. This is very informative, important. So previous Ferret was working based on clip, and the clip is trained based on image and text description, and because of that clip cannot work with patches. But Dino v2 in the paper they specifically mentioned that they have trained the Dino v2 on patches too, so Dino v2 has a better understanding of patching. So when they're talking about any resolution, uh, in one of their experiments in this Ferret-v2 they applied the clip for the patches and they understand no, that's not going to work. Then they change it to the Dino for patches. So basically, they are using two models. One is Clip for a global feature and applying to the whole image, and another one is Dino v2 that applying it for patches. And then there are some upsampling in the middle, and they're combining these together. So, and number three is three-stage training paradigm. So this is also important. So previously, the way that they trained the model was first they fine-tuned the model for the image and description, and then they fine-tuned the model on the detailed um, questions. For example, for alignment and sorry for instruction tuning. But with this new approach, they're talking about another intermediate level of training. So they said, beside image caption alignment, which is the first step, an additional stage is proposed for high resolution dense alignment before the final instruction tuning. So in this middle step, actually what they are doing is for every object in the image, they are asking a specific question like describe this object in this position or where is that object located, stuff like that. And that is like intermediate um, training that improve the model performance on grounding and referring. And they showed that the experiment results showed that preferred V2 is actually better. So that's the whole idea of the paper. Let's go down. I don't want to go through many of these stuff here. I actually explained them when I was talking about the abstract. So they're showing here in this diagram. Let me zoom in a little bit. Um, So they are showing here that comparing the any resolution with upsampling method, there is another way of upsampling method. They mention it in the top. that direct upsampling is another approach, um, and they reference it from another paper, and they're showing that any resolution works much better than direct upsampling. And let's go down and see what we have explained so far. So we said that like we have the whole image, we pass it through the clip, then we have an MLP layer or linear layer that we project that to the features that we want. And for each patches, for example, 4x4, we apply Dino V2 when we have another projector and we have four, or based on the how many patches we have other features. And at the end, they are doing merging these together. And basically, they are concatenating these patches plus upsampling this one. And then they have a spatial aware visual sampler. We'll talk about this later. This is not explained in this paper and very vaguely explained in the previous version of the paper, but looking at the code, you will find out that it is mostly using that affine transform. And so basically in the visual sampler, they're using uh, using this, which is one of the function in the PyTorch grid sampling. Um, we will reach to that point. Let's jump to the next part. So then we have like for a text, like can you describe this text and describe this object in this region? And these are like some continuous feature of that object. And they embed these ones. This is for training this continuous explanation. And then they use this text and use some attention mechanism for a visual sampler and pass it to the language model. For language model, they said they're using Vacuna, but actually in the code I've seen Llama, they're pretty similar. So they are freezing this. They are not training this one. And also for the embedding, I think they are not training this again. The only thing they are training, also Dino is not trained. Only thing they are training is the projectors here and a spatial aware sampler, and that's it. So let's go down. So then they're talking about the architecture. We talked about that. So patches, we applied Dino, then we pass them through the MLP, and then you will see here. Um, So they're talking about model training paradigm. So first they have just image captioning alignment, then they have high resolution dense alignment. So in the high resolution, then they are just mostly training like model capability for referring and grounding. And then they have in instruction tuning, like for this kind of instruction, you should provide what kind of answer, going to the more detail for the model. And they have some ablation study showing that this step was really helpful for grounding and uh, finding the references. And at the end, as I said, so they have concatenation between the patches features, and then they upsample the general feature because general feature, like if you imagine that like we have, for example, n patches, the effect of patches can be more than the effect of the global feature. So for that, they're just using the upsampling via interpolation. That help to not only focus on the detail, but also global feature can get impacted better. And they're talking about paradigm of training that we talked about that. So this is for performance for the state of the art, like one of the other model that published basically for example, you can see for OCR extraction from invoice or stuff like that, IDFSS was pretty good. But I think Ferret, I'm not sure about the OCR accuracy, but this is for example, visual question answering or like some other benchmark that's showing Ferret is going pretty good comparing to other methods. Recently, I think they published another thing, Ferret UI, that this is the same Ferret, but trained on the UI dataset. For example, for Android or for other UI, you can see like here, Ferret is able to understand the UI. So maybe this is like one of the pathway through agent that the OpenAI said they have trained like some agent to interact with computer and find out like where is the mouse position or what kind of key in the keyboard need to type where, something like that. So this kind of model I think can be pretty good on that, because if you look at Ferret, the first version of that, it's able to handle a kind of hybrid region representation. Like you can see that this can be like a segmentation. So if you want to read a website using a model, or you want to interact with that, I think object detection is one way, but it's also, if it is getting complicated, models like this that have um, like any kind of region representation is pretty powerful. I hope I was able to convey most of the meaning, but the main point is, if you have high resolution, go with patching and Dino V2, which is any resolution plus Dino V2, and that's it. Thank you. Have a wonderful day.